Hello everyone, in this video we are going to use Jamovi in order to help us do a one sample test of proportions. So our scenario is that Damien is really interested in dental health in Casper. There recently was a report that 85% of people floss every night. Damien thinks his proportion is too high. He decided to send out a poll to randomly selected people in Casper to determine if they floss every night. He wants to test at an alpha level of 3%. His collected data is shown below. I'll just go ahead and copy our data. We're going to move it over to Jamovi. Just paste it right in. We'll rename this just a better label than like A, B, or C. We'll just label it as floss. Now that we have this in, let's go ahead and answer some of our preliminary questions. So first of all, the type of data that we are dealing with here is categorical. And the distribution that we're going to be using for our test is actually either the chi-squared or the z distribution. There's a couple different ways that we can actually do a one sample test, and I will take either one. If you do it by hand, it'll be a z. If you do it in Jamovi, we'll get a chi-squared. So the equation that we're going to be using, if we do it by hand, is this z equation. But if we use Jamovi, we actually use this chi-squared, where we're looking at the observed and the expected proportions. We'll dive into this equation actually later on in class, but for right now, I will take either of those answers for what equation should be using. Okay, so next, what is the population of interest? So here we're actually trying to talk about everyone in Casper. Trying to say it's a proportion of people in Casper who actually floss. So the parameter of interest is the true proportion who floss nightly. Okay, and then is our sample size sufficiently large to do our analysis? This is a good question, and this first one that we can actually use Jamovi to help us out. So this comes back down to, it's like, can we use, is the central limit theorem enabled to be enacted so that we can actually make an approximation of this categorical data with a normal distribution? It's kind of basically where it's at. So when we do this, let's go ahead and look at our exploration, and we're going to look at just some descriptives. All we're going to do is we're going to pull floss over, and we're going to look at this frequency. Okay, so we have this frequency, and with our frequencies, it kind of shows us how many we have and how many yeses who said that they did floss every night. They didn't floss. So if we go back and narrow this down, so that's our full table. The other thing that we can do is we want to actually see how many do we expect. So what we would do is we'd take this 110 and multiply it by 85%, and it'd be how many people do we expect to say yes and how many do we expect to say no if the null hypothesis is true. Now we could do this by hand, or we can actually have Jamovi do it for us. So if we go to our analyses, we're actually going to go to our frequencies here. We're going to do this chi-squared goodness of fit under our one sample proportion tab. Let's go ahead and click on this. What we're going to do is we're going to grab our floss, we're going to bring it over, and we're going to bring in our expected counts. And our expected counts are as shown below. Now this is if we had a 50-50 proportion. Now, if we change these proportions to the yes, our hypothesis said that the yeses were coming in at 85%, and that the no's were then coming in at 15%. Okay, so that's how we get these expected. We have 93 expected for the yeses, and then like almost 17 expected for the no's. And so essentially we have at least 15 expected successes and the 15 expected failures. We can go ahead and do our test. Okay, so let's go ahead and do our hypothesis test now. So what we are going to do is we are dealing with proportions. So we're dealing with the true proportion going to be equal to, and we're doing this 85% because that's what the analysis said. And we thought that that was actually too high. So we think that this 5 is actually too big. We think that the true proportion is less than that. The alpha that we set up was 3%, and that just gave it to us in the problem right here, percent. And then we need to calculate some test statistics and some p-value stuff. Okay, so let's go ahead and grab a few things. So we need to look at what was the sample proportion that we got, and we have it right here. It's 0.75455. 5. We have an n of our total sample. How many people did we have? Up here, 110. And then I have chi-squared or z that we can put in. Let's just grab this chi-squared value right here. And it is 7.8610. There we go. So rounded to 4 decimal places. And then we have this p-value. Okay, now in Jamovi, Jamovi always assumes that we are doing a two-tailed test when we are here doing this chi-squared goodness of fit. Now, if we want to do a one-tailed test, we can do it. We just have to divide our alpha by 2 because of the steps that happens in Jamovi, it winds up getting doubled. So here's what we're going to do. We're going to take this p-value and we're going to divide it by 2. So I'm going to go ahead and grab our editor, because I can just do it right here inside of Jamovi. And I'm going to do, real quick, let's digits equals 12. 10 is fine. Just so that we have some more significant figures. I'm going to put it to I show the code and the output. And then all I'm going to do is 0.005053. I'm going to divide that by 2. And let's run that guy real quick. And I get this 0.002525. And our p-value is 0.0025. Great. 0.0025. Perfect. Okay. Now, if we were doing a two-tailed, let's say that this was a not equals 2, then we would just leave that p-value alone. It's correct. But if it's one-tailed, like it is right here, then we need to divide that p-value that Jamovi is going to give us by 2. Okay, so here we go. The p-value is less than alpha. And let's get ourselves a confidence interval. Confidence interval is actually pretty easy. We're going to use the same technique that we did before. So let's just go to ESCI, estimate a proportion. We're going to grab floss, bring it over, and we want a confidence level of 97. Now the problem here, remember, is that if we do 97, that's going to always assume two-tailed. So we need to actually double our alpha to 6. Would then give us a confidence level of 94. Now this would give us both if we were doing a one tail greater than and a one tail lower than, so you have to choose which one that you want. Go ahead and hit enter real quick. And let's see what we have. So these are our confidence intervals, lower and upper. Since we thought that it was greater than, we thought that this value was too big. So we think that ours is smaller than. So our confidence intervals said, hey, we think that the true proportion is no greater than some value. Here, the lower end is going to be 0, and this upper end is going to be this 0.82299. And if we look at these, 822. Our decision is that we are going to reject the null hypothesis, and we're rejecting because our p-value is less than our alpha. The other way that you can see is that 0.85 is not inside of our confidence interval. Okay, so then down at our conclusion, we can say that we have collected sufficient evidence. And we can either do it with the chi-squared or we can do it with z. And we're going to say collect sufficient evidence to reject the claim that the true proportion who floss nightly of everyone in Casper is equal to 0.5 and conclude that it is in fact less than 0.85. We can say that we are 97% confident that the true proportion who floss nicely of everyone in Casper is somewhere between 0 and 0.23. And when we look at this, both of these are actually correct. If we did it with our z value and we did it by hand, with this guy, and if we don't, do it with the chi-squared. Okay, and that's how we do one sample proportions testing. Good luck on your